Hi, good morning. So I hope you're all in the good situation, and today I'm going to discuss with you about the angles and some of their properties. Now, normally when we teach our kids, it's good actually if we can give them like a, motivational question. So I remember when I was a young kid, my father, he taught me many things, and sometimes some of those questions I still remember until today. For example, when I learned from him about the angles, he asked me this: so how can you prove if the interior angles of a triangle it's 180 degrees? So, of course, the question like this is important because what happens is normally when our kids learn about this from school or from someone, they just memorize this fact, that the total angle inside a triangle is 180 degrees, or the total angle inside a quadrilateral, or in bahasa it's called segi empat, it's 360 degrees. Well, it's good, but when the kid can provide how or why that can happen, I think this will give them a bit further knowledge, so hopefully they can go further with that to master some other stuff also. Now, sometimes for us now, it's quite challenging to find this kind of question to ask for our kid when we try to teach our kid. But see, what I'm doing is actually I'm trying to give you some alternatives, for example, the question that you can ask for your kids before you start to teach them. For example, now probably you can start by asking him like this: if you look at again in the history of time, when the Egyptian people, the ancient Egyptian, they built the pyramid, yeah. Now you can ask to your kids actually, how can they have the exact 90 degrees for the angle at the the base of a pyramid like this? So this is a pyramid. I just make it from straw, and you can ask that question actually: how can the Egyptian make this angle exactly 90 degrees? Because at that time when these Egyptian people made the pyramid, yeah, it was long before we know about the what we call it Pythagoras formula. You see, a square plus b square equals to c square. So long before that formula was invented by Pythagoras, these Egyptian people actually didn't know about this fact. They know that there is an angle 90 degrees and how the sides of the triangle associated with this angle. So it is very interesting question actually you can ask, because at that time we don't have tool like a protractor that they use now at school to measure the angle. So perhaps you can ask this question, and later if they know the answer, and then you can ask further question. For example, in 200 BC, around that time, there was a man named Eratosthenes, and this man actually calculated the diameter of the earth. And there was amazing discovery at that time, because he only used a simple method to calculate the diameter of the earth. Okay, so explain about how the Egyptian got the 90 degrees angle at the base of a triangle. Now let me start with this lesson first, okay? So today we are going to discuss the some properties of angles, yeah? The properties of angles, and normally we will start with a straight line. So if we have a straight line, and now we have another straight line, for example, like that, and they intersect at a point here. So we will get some angles. You see we have 1, 2, 3, 4. And now normally when we have an angle here, we can measure how big the angle is using a protractor. So let me show you how it looks like here. So this is how protractor looks like. And I guess your kid must have this tool, because when he tried to measure the angle, for example, the angle between the blue and the black line here, you need to know how to use it, yes. So you see in the protractor, we have some numbers here. And what happened is actually we have from 0 to 180. Now with the blue numbers here, it starts from here, 0, and then it finishes here, 180. Or if you start from with the black numbers, we have 0 here, and then it goes to 180 here. So in this case, it doesn't matter if you want to pick one of them, yeah? So in this case, I'm picking the blue one. So we'll just put the scale 0 line exactly at this one of the lines here, the blue one, for example. And then we see now when we look at the other line, yeah, this black one, it goes into this scale. And if you look at here, 0 and then 10, 20, 30, 40, and 50. And the black line is in between 40 and 50. So now we just need to look at this smaller scale here. So this is 41, 42, 43, 44, and 45. That means this angle, the smaller one, well, it's about 45 degrees, yeah? So normally when we have the angle which is less than 90 degrees, we will call it as an acute angle. So again, acute angle is just simply the angle which is less than 90 degrees. Now, if you look at the other angles, yeah, for example, now if you just want to measure the, okay, so let me have slightly similar situation. So we have these two lines again, and now you want to measure the bigger angle here. Okay, let's put now the protractor. Here we go. So let's bring it down here and then just give a bit rotation there, and then put this point, you see that 0, yeah, that point exactly at the intersection. Okay, so now you see this black line is exactly located at 0 scale, and then we'll just look at the other line, which is the blue one now. And now it goes from you see 60 to, oh sorry, it is in between 120 and 130, okay, 120 and 130. That means if you look at the scale now, 121, 22, 23, 24, 25, 76, 27, 28, 29. So this is about 129 degrees. Now, if the angle is larger than if the angle is larger than 90 degrees, we call it obtuse angle. So again, if the angle is less than 90, we call it acute angle. If the angle is greater than 90 degrees, we call it obtuse angle. My writing is not that good actually. Okay, let me write it down again. Here we go. Great. Now, there are some special angles. For example, if you have two lines exactly intersect and the angle in between here it's 90 degrees, yeah. So this angle is called right angle, and this is very important stuff that I asked you in the beginning, how the Egyptian people, when they built the pyramid, they know exactly if, you know, the angle at the base is 90 degrees. I'll answer this at the end of this discussion, okay? Now, now I'm trying to introduce you some of the basic properties. The first one is called the complementary angles. So what are they actually? Okay, the complementary angles, basically they will add the angle to 90 degrees, okay? Now, you have seen before the 90 degrees angle, or we call it right angle. And now let's suppose we have two angles in it, yeah? So we have, you know, the first one, it's this one, and the second one, it's this angle. All right, so this is the first angle, let's just call it X, and then this one, it's Y. And as you see here, that the X plus Y will make 90 degrees. So here we say that X is the complement of Y. The example of it is, for example, X is 40 degrees, and the complement of it will be 50. Or you can find the other example, you know, 30 is the complement of 60 and so on. Okay, so that's the first property that you need to know, the complementary angles. What are they? They make 90 degrees. All right, now the second one is called the supplementary angles. So these angles will add the angle to 180 degrees, yeah? So for example, if you have a straight line, yeah? Now, if you have two angles in there, so this is the first one, and then we have the second one, and let's just call it again, this angle X and this one Y, so X plus Y, they make 180. Now, it's said here that X is the supplement of Y, okay, or you know, Y is the supplement of X. Now the example of it, for example, if you look at our previous example, yeah, so we can say, for example, 45 degrees, it's the supplement of 135. 60 degrees is the supplement of 120, and so on, right? So that's the second one. Now, I'll go with more higher stuff. So the third one, now let's suppose you have a straight line, okay? And then we cut this straight line by using two parallel lines. So parallel lines, meaning that if you put the protector, yeah, they don't make an angle. So basically we call it they are parallel, they are in the same direction. And this is the symbol if you want to say, okay, they are parallel. Yeah. Now, you see, when you use your protractor and then try to measure some angles in it, yeah, we have now something like here inside and also another one here. So this angle, they are corresponding angles. So it's like making the letter F, okay, corresponding angle. In our native language, Bahasa Indonesia, it's called sehadap. Okay, so for example, if this angle is 120, therefore this also equal to 120. Yeah. And you see, we can also find the other corresponding angle. For example, this one and this one, yeah, they are also corresponding. So in this case, they are 60 and 60 because this 60, it's the supplement of 180, okay? So it's corresponding angle. Now, the fourth property, we have something so-called the alternate angles. So again, if you have a straight line and then you cut this straight line by using two parallel lines, yeah, parallel. Now look at this. If you try to make like this letter Z in there, yeah. Now we have the first angle here and also the second one here. So they are alternating angles and they are equal. So if this is X, this is also X. Yeah? For example, if this is, let's say 60 degrees, this is also 60 degrees, yes? Because they are alternate angle. They are making letter Z like this. Great. In our Bahasa Indonesia, it's called dalam berseberangan. Okay. Now, the fifth property that I consider also important, it is vertically opposite angles. Now, basically what we have here is just, you know, two intersecting lines like this, and we can see here this angle and this angle, they are equal because they are vertically opposite. And also this one and this one, they are also equal because they are vertically opposite angles. Yeah, so for example, if this is 75 degrees, this is also 75. And if, you know, this is 75, therefore X has to be 105 degrees. Why? Because they are supplementary one another. So they make 180. Right, vertically opposite angles. In Bahasa Indonesia, they are called bertolak belakang. Right? So now if you look at again from number 3, corresponding angle, yes, making letter F, and then alternate angles, making letter Z, and then vertically opposite like this, yeah, they are equal. Now I will come to the very last one, which is number 6, and we call it co-interior. What happened is like this. So if you have a straight line and then you cut this straight line by two parallel lines, yeah, we have now this angle and this angle, and they are co-interior one another. So if you imagine here, they make letter C, co-interior. And what happened with this angle co-interior? They are not equal, okay? But they make 180 degrees. So x plus y equals to 180 degrees. Why that happens? Because you see, if you have this y, therefore this angle here is also y. Yeah, because remember, they are corresponding. They are sahadat. Okay, they are corresponding. So this angle and this angle, they are the same. And now if you look at this y and x, because they are along the straight line here, and then what happens is they make 180 degrees. Okay. Now, there was a practice question like this. So let's suppose we have a triangle here, and this triangle is made from 3 intersecting lines like this. Now it's given here that the angle here is 120, and then let me have a look again, the other angles here. This one, it's 52. Right, so, and then this one, it's 68. Now, there are some unknowns number here. So the first one is located here, and the angle here is 2 times x, the variable, the unknown variable x. And then another unknown is located here, and it's 3 times y. And then the other one is here, it's 5 times z plus 3. Of course, the question is how or find the angle x, y, and z. Okay. Now let's look at again here the first one with this angle, because you see 180 and this angle 2x, they are vertically opposite. Yeah, I was just saying opposite. They will be the same, they will be equal. So in this case, 2x equal to 120, and therefore the angle x equal to 60 degrees. It's the value of x, yes. Now, if you look at again for y here, we have also similar situation. So in this case, 52 equals to 3 times y, and therefore y equals to 52 degrees divided by 3. That's it. And you can always use calculator to get the value of it here, 52 divided by 3. And then the other angles here, 68 equals to 5z plus 3. Well, you need to be careful when you evaluate the value of z, because you need to do the right algebra. Yeah, that means 68 minus 3 equals to 5 times z, yes, and then 65 equals to 5 times z, and we got the number now, 65 degrees divided by 5, which is 13 degrees. So that's the answer. Now, remember in the beginning, well, actually this is from my father when he asked me why the angle inside a triangle. So this, and this, or let me just call it x, y, and z, they make 180. Well, it's actually quite easy question for us if you already learned about this stuff. But imagine at that moment when the kid just started to learn about this stuff, and then you ask about this thing, perhaps they will answer, well, that's what I remember, that's what I learned from school. Okay, now if that's the answer, we can try to guide them how we can get this 180. Okay, so it's actually not that difficult. You know, we can sketch a straight line. For example, we can have a straight line somewhere here. Yeah, at the base. Okay, now we'll try to draw parallel lines to this line. So we have another line here passing through this point here. So this line is parallel to that line. Okay. Now, if you look at here, we have same angles, this one and this one, right? So this is also a angle. Why is that? Because they are corresponding angle, or we call it sehadap. Now, if you look at this angle Y, this is actually also the same angle Y. Yes, because they make the alternating angles. Okay, so this is like you have a letter Z in there, and this angle equals to the Y. So now if you look at this Z, Y, and X, X, Y, and Z, they are in the straight line. This straight line, the purple one, and as you know, if we have a straight line, the angle of that has to be 180. So there are quite many basic questions like this, and if you can ask this question to your kid and they can answer it, they will benefit for them also. Okay, so now I'm going to stop and then go back to my explanation how these Egyptian people built the angle of the base of the pyramid equal to 90 degrees. So you see, before we discover the Pythagoras formula, actually the ancient people already know about this mathematical fact. Okay, and what they do is actually, I think, very clever. Okay, so basically they just use a rope. You can use any rope, like for example this one, and then they will create some nodes. Okay, they will create some nodes from the rope. Okay, so for example, you see this one, and then they will create another node which has the equal length from the previous one. Okay, so you see this and the next one, they are the same length. Yeah, and I'll just show you what I got here because I already done with that. Yeah, so this is basically what they have. Okay, see, they have 12 nodes. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 12, and the end. Yeah, so in this rope, actually, they have so they have 12 equal length. Yeah, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Now what they do is very clever actually, because from the 0, 1 until here they put something, yeah, and then they will bend it, okay, and bend it again. So I'll show you what I'm doing later, because you need to check this, yeah, on something that I already prepared. So this is what happened actually. If you look at what happened with the rope, yeah, again, there are 12 length, equally the same length. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then when they try to connect the tail and the head of the rope, yeah, like at the same point like this, and then you just put there. So what happens is actually if you have 4 length here and then 3 length here and then 5 length here, this angle will be exactly 90 degrees. So they make this angle by doing this rope, and then they just put it on the ground. Yeah, they just put it on the ground, and then they just make it a bit longer to different direction. Yeah. So at the end, they will make sure that this angle at the base of the pyramid equal to 90 degrees. I think that's very clever mathematics skill that they have in the ancient time. And if you can ask something like this to your kids, how, you know, those Egyptian people got the 90 degrees, and they have the idea or an answer, I think it will be very nice. Yeah. But of course, if they don't know, you can explain, or this is, you know, like an activity for them, so they can try to look at something very simple but useful like this one. So I think I'll just stop here, and probably next topic we will discuss something different. Yeah, and I'll try to find different motivational question for your kids. Okay, and hopefully this video will be useful for you. Right, I'll see you next time.